One other approximation that we want to be aware of for the exam is a trapezoid approximation. You see trapezoid sum, it's really a trapezoid approximation, which basically is, instead of having a whole bunch of rectangles, we're going to have a whole bunch of trapezoids. All right, so here's our function right here, and so if we're starting at A and we're ending at B, all right, and what we're going to do now is we'll just make some trapezoids. And we can see that if we make some trapezoids, that depending on how wide or how many trapezoids we have, they can actually be rather close to the function itself. They might be off a little bit, and this one is particularly wide, but if we have a lot of trapezoids, then we are looking at a very accurate approximation for the area under the curve. Now, a trapezoid approximation is not a Riemann sum, because a Riemann sum specifically talks about making rectangles and finding their areas. We're basically doing the same thing right here. We're just making trapezoids, finding their areas, and adding them all up. So, how do you do that? Well, you just need to recall your area of a trapezoid, which we know is 1/2 times the height times the sum of the bases. So you just have a whole bunch of trapezoid areas written out, and you can add them all up. Now, if you're having issues with recalling the formula for the area of the trapezoid, you do have another choice, and that is that you can do a Riemann sum. Right? In fact, you got to do two of them. If you do a left and a right Riemann sum, and then you average them together, that will give you the same result as the trapezoid approximation. Right? By definition, the math works out perfectly, so you can always do a left and a right and average them. Right? Now, you see here another quicker way that I've written down. First of all, there's an error in here. This should be 1/2 times delta x. If you are talking about a trapezoid sum with equal subintervals, like we had in example 8, then if you do 1/2 times delta x times this, basically we count the first y value once, we count the last y value once, and we count all the middle y values twice. With the way that the trapezoids work, you can use this formula as well that's written right here, but it does need to be equal subintervals, and often on the exam you're not given equal subintervals. So it's best to either work trapezoids or to do the average of the left and the right Riemann sums. Let's take a look at example number 9. Right? So here's our function g. We're looking to approximate the area under the curve with a trapezoid sum with 4 subintervals. Okay, so again, you can go left sum and right sum and find their average. I'm actually going to do this problem using the area of the trapezoids. All right, again, area is 1/2 times the height times the sum of the bases. Now you can pull the 1/2 out front if you'd prefer, since you're actually doing 1/2 in every single trapezoid. I'm going to write it down for each one, but again, it's completely up to you. So again, we are looking to approximate the area under the curve. So we're looking to approximate the integral from 0 to 8 of g of x dx. All right, we know that this is the exact area under the curve. We're looking to approximate it, and we're going to do so with a whole bunch of trapezoids. All right, so let's get going. So we have our first trapezoid. It's going to go from 0 to 2. All right, so that's 1/2. There's always there. The height is the change in x. All right. We know that if this is the first part and this is the second, if this is the first part and the second part, the height is always the distance between the two bases. And the bases are the parallel sides. So we have 1/2, and the change in x is 2 units. So that's our height. 1/2 times 2, and then the bases are the two parallel sides, which are the two given y values, 12 and 13. So we've got 12 plus 13. And we go to our second trapezoid, which is going to travel from 2 to 5. So that's a height of 3. So we're going to have 1/2, height is 3, and the two bases are 13 and 15. Next up, we're going from 5 to 6. So that's a change in 1. So 1/2 times 1 times 15 plus 18. And finally, our fourth trapezoid, we're going from 6 to 8. So that is a change of 2. So we have 1/2 times 2 times 18 plus 16. So if you notice, we used the 12 and the 16 once each, but then we used the 13 twice, the 15 twice, and the 18 twice. The three values in the middle were used twice. Okay. So what do we have here? Well, 1/2 times 2, they wipe each other out. 12 plus 13 is 25. Okay, and then we have, well, these don't wipe out at first. So we have 1.5, and then we have 13 plus 15. So 13 plus 15 is 28. Half of that is 14. 14 times 3 is 42. All right, and then 15 plus 18 is 33. Times 1 is 33. Half of that. So we're looking at half of 33, which is 16.5. And then half and 2, they wipe each other out. So we have 34 right there, 18 plus 16. And we can put these together. 34 and 25 is 67. Plus 34 puts us at 101, plus another 16.5. So we're looking at 117.5 as our answer for example 9. And example 10 is more of the same. Trapezoid sum with 4 subintervals, measuring the approximate area of the cross section of the river. So this is a classic type of problem you could see on the AP exam. But again, what we're looking at is here's our change in x, and then our y values are right there. So we're looking at change in x of 8, and then 6, and then 8 again, and then 2. All right, and so what we have here, again, 1/2, right, approximately equal to 1/2. The height is 8, and the sum of the bases is 0 and 7, plus, and then 1/2. We have a height of 6. The sum of the bases is 7 plus 8. And then a height of 8 for our third trapezoid. And then 8 plus 2. And finally 1/2. And then a height of 2. And then 2 plus 0. Now, just keep in mind that on the AP exam, you are not required to simplify your arithmetic. So if you were given this question on the exam, and you wrote this down, okay, you have shown the computations that have led to your answer, this would give you full credit. Okay, as long as you're doing a trapezoid approximation, trapezoid sum, so you're showing the trapezoids in their mathematical formulas, you do not have to simplify this. If you leave your answer like this, you would get full credit. Okay, if you then go to simplify this answer and you make a mistake, for example, you say 8 plus 2 is 11. Now it messes up the entire answer. Lose a point for that because now you have incorrect math down, whereas if you stop right here, you actually have everything done correctly.